Hello everyone. Today's our topic is General Chemistry for semester first, MSc first year. Subject code is CHG 190. It is elective option for General Chemistries part 1, that is Introduction to Solid State of Matter. So syllabus for this solid state of matter is bonding in solids and electronic properties, that is first chapter. Introduction, bonding in solids, free electron theory, electronic conductivity, then molecular orbital theory, MOT, then simple metals, semiconductors, PN junction diodes, then transistors, then gallium and arsenide compounds, bands, Indi block compounds, and monooxides. Chapter number 2 contains defects and non-stoichiometry. Introduction of that chapter, that is point defects, then defects and their concentrations, intrinsic defects, extrinsic defects, then applications like fuel cells, sensors, electrochromic devices, non-stoichiometric compounds, etc. Then chapter number 3 is superconductivity, which contains introduction of that superconductivity, discovery, the magnetic properties of superconductivity, Josephson's effect, then high temperature superconductors, theory of high temperature superconductors, uses of that superconductors. Then chapter number 4, that is synthesis of solids, common reactions employed in synthesis, then soft chemistry routes, ceramic methods, decomposition of precursor compounds, combustion synthesis, mechanochemical and sonochemical methods, then which is soft chemistry routes like ion exchange reactions, etc. Then fluxes, uses of fluxes, sol-gel synthesis, electrochemical methods, hydrothermal, solvothermal and ionothermal synthesis, then chemical vapor deposition and atomic layer depositions, then procedure of synthesis of some nanomaterials like gold and silver nanoparticles, then zinc oxide and Fe2O3 nanoparticles, and porous silica. So there are some references for that CHG 190. Okay, so you can use Mori, Leslie and Rao, Krishnan, Biswas books, etc. Then our first topic is, that is bonding in solids and electronic properties. So before that we will discuss law of symmetry. So what is law of symmetry? Symmetry of crystal is very important concept in crystallography. That symmetry of crystal is determined with respect to plane, that is a line or axis, a point, that is center or center of symmetry, and plane of symmetry. There are line of symmetry, center of symmetry, and plane of symmetry. All crystals of the same substance possesses the same elements of symmetry. In other words, if two crystals have same element of symmetry, then these are of the same substance and same type. Okay, so there are different types of symmetry. First one is a plane of symmetry. If a crystal is divided into two equal portions which are mirror images of each other, if the two equal portions are mirror images of each other by imaginary plane, then the symmetry possessed by crystal is called plane of symmetry. And cubic crystals has 9 plane of symmetry. Okay, so this is plane of symmetry. Second point is axis of symmetry. If a crystal is rotated through 360 degrees centigrade around the imaginary line or that imaginary axis or imaginary line that is passing through the center of the number of passing to the center, and in the number of times crystal appeared unchanged, is called axis of symmetry. If that crystal rotated through 360 around the imaginary line or the axis, that axis passing through the center, and the number of times that crystal appeared unchanged, so that number is called axis of symmetry or line of symmetry. That number is called folds or folds of symmetry. or that line is called axis of symmetry or line of symmetry. If crystal appears unchanged 2 times, then crystal is said to possess two-fold axis or two-fold axis of symmetry. Similarly, if crystal appears 3-4 times unchanged, then it is called threefold, four-fold axis of symmetry. Okay, so this is second point, that is axis of symmetry. Then next is crystal system. What is crystal system? There are 7 basic shapes of unit cells of crystals, which gives rise to the 7 crystal systems. So that 7 crystal systems are cube, tetragonal, orthorhombic, monoclinic, hexagonal, rhombohedral and triclinic. Here in this picture there are some crystal systems. Okay, crystal systems are characterized on the basis of angles between the edges of the unit cells, that is alpha, beta and gamma, and the length of edges, that is A, B and C. There are length of edges, there are 3 edges A, B, C. So angle between the edges and length of the edges determine the shape and size of the crystal. So overall there are 230 crystals practically observed. They are grouped into 32 classes on the basis of symmetry or molecular symmetry, and then into 7 crystal systems on the basis of shapes of unit cells. So 7 crystal systems are cubic, tetragonal, orthorhombic, monoclinic, hexagonal, rhombohedral and triclinic. Now we will discuss crystal structure. What is crystal structure? A crystal lattice is 3-dimensional ordered arrangement of basic units, that is unit cell. So unit cell is the smallest repeating unit of a crystal from which 3-dimensional network called crystal lattice. So that is crystal lattice and is formed in unit cell. So that 3-dimensional network of that crystal is called crystal lattice. So there are 3 major types. First one, that is structures of solids, 3 types of unit cells or 3 major types. First one is a cubic or simple cubic or primitive type. Second one is body center cubic, and third one is face center cubic system. As we see in the figure, there is simple cubic, body center cubic, that is BCC, and third one is FCC, face centered cubic system. So what is simple cubic system? First one, or primitive cubic unit cell or primitive system. In simple cubic system, atoms, molecules or ions are arranged at the corner of the cube. In this primitive or simple cubic system or simple cubic unit cell, the atoms are present only at the corners. So every atom at the corner is shared among 8 adjacent unit cells. So there are 4 unit cells in the same layer and 4 in the upper layer or lower layer. 4 in the upper or lower layer. Therefore, a particular unit cell has the only 1/8 of an atom. So each small sphere in the following figure represents the center of particle that occupies the particular position and not its size. So this structure is known as an open structure. The atoms in the primitive cubic unit cells are present only at the corners. So there are 8 corners. So 1/8 of an atom is there. Every atom at the corner is shared among 8 adjacent unit cells. So 4 unit cells are present in the same layer and 4 unit cells in the upper and lower layers. Therefore, a particular unit cell has the only 18th of an atom. Each small sphere in the following figure represents the center of particles which occupies that particular position and not its size. So here in this figure we can see there are 8 corners. So 8 corners, each corner shares 1/8 atom. So there are 8 atoms at the corners. So the total number of atoms in 1 unit cell is 8 into 1/8 is equal to 1 atom. So in simple cubic system or cubic unit cell or primitive cell, there is only one atom. The next type is body centered cubic system or body centered cubic unit cell, that is BCC type. A BCC unit cell has atom at each corner of the cube and an atom at the center of the structure. The diagram shown below is an open structure. Here in this diagram we can see open structure, that is BCC. According to this structure, the atom at the body center wholly belongs to the unit cell in which it is present. In BCC unit cell, every corner has atom. In this case, there is 8 corners. BCC means body center. 8 corners and 1 units and 1 atom which is present at the center of the body of that cube. That is why 8 corner plus 1 body center atom. So in BCC unit cell, every corner has atoms and the contribution of that atom is 1/8. Therefore, is one atom present at the center of the structure. There is one atom present at the center of the structure. So, below diagram is an open structure. This is an open structure. So, there are 8 atoms at the corners and 1 atom which is present at the center of the cube. So, 8 corners contribute 1/8, that is 8 corner into 1/8 is equal to 1 atom. And 1 body center atom, that is 1. So 1 plus 1 is equal to 2. Therefore, the total number of atoms present per unit cell is equal to 2 atoms. So the total number of atoms present per unit cell in BCC system is 2 atoms. Third case, that is face center cubic unit cell. In this system or in this FCC case, atoms, molecules or ions are arranged at the center of each face of cube in addition to the corner of cube. An FCC unit cell contains atoms at all the corners of the crystal lattice and at the center of all the faces of the cube. So that cube is having and only 1/2 of each atom belongs to an individual cell. In FCC unit or face center cubic system cell, atoms are present in all the corners of the crystal lattice. Also, there is an atoms present at the center of every faces. So there are 6 faces. This face centered atom is shared between 2 adjacent unit cells. 12 of each atom belongs to a unit cell. So in this structure or in this FCC unit cell, 8 atoms which are present at the corner and the contribution is 1/8. 8 corners and 6 face center atoms. Okay, so each face shares half atom. So there are 6 faces. So 6 into half is equal to 3 and 8 atoms are at the corners, that is 1/8 atom. So 1/8 into 8 corners is equal to 1. So 3 plus 1 is equal to 4. Hence the total number of atoms in a unit cell is equal to 4 atoms. So here we can see in this structure 1/2 atom at 6 faces and 1/8 atom at 8 corners in case of face center cubic system. Thank you.